operator operand format, we've also seen that there are certain types of, okay, so basically there are these kind of instructions, ternary, binary, and so on and so forth, and this is how it is taken. So let me just briefly draw them again. So you can have an explicit instruction, okay, which is just one word. I'll tell you what is a word in a minute. Then that instruction looks like this. We are drawing square boxes for instructions and circles for data. So this is the instruction. So just the operation code is there, and if the operation code is received, then we don't need to mention any more data. It will know exactly what. For example, halt. That means halt all operations. That means halt all operations. Or let's say shutdown. These may not need any parameters at all. Okay. In for example, in C, you use a a function called exit. Have you ever used this function? Exit. Okay. So what does that do? That actually exits the program totally and gets you back to the operating system. So this exit, now it may be implemented as an explicit operation, which means that no additional data are required. No additional. If you do something like this, now if you do something just like this, exit, okay, that's a different. But if you give it some sort of a data, then it becomes like, for example, if you do exit 1, this actually means it's an error code. So there, this may be not very explicit, not explicit, because you have to give it because of the 1. So because of the 1 as an error code. So in that case, we may have a unary instruction which looks like this: operation data. Then very similarly, as you've seen yesterday, I'm just repeating some of yesterday's now. We may have binary. For example, binary operation, and then we can have ternary operations as well, okay, where we can, there is an opcode, there is a first data, second data, and a third data, although this is very rare actually. Generally, we have up to binary operations. Now, when you talk about, here we are distinguishing by way of a square and an ellipse or a circle, whatever, and obviously a circle is nothing but an ellipse. But you see, these are all numeric codes, as you know, and each of these are one word each. Now, you may tell me then, and you may ask me, or rather, let me ask you this. Do you happen to know, when we talk about computers, what is a word? No, it refers to memory size. It refers to data size, rather, not memory size, data size. What is a word? Anyone else? No. Anyone else? So one word basically the lowest allocable memory unit. It is the lowest allocable memory unit. Normally in multiples of bytes. So if the if the word size is 1 byte, okay. So if the word size is, so if the word size is 1 byte, that is 8 bits, the data have to be represented at least using 8 bits. Okay. It also refers to the size of the accumulator. As you know that the accumulator holds the intermediate values of operations. It holds the intermediate values of operations. So that is a byte, or rather a word is the largest that you can accommodate in the accumulator at the same time. If the data happens to be larger than a word, then you have to deal with it twice. For example, if the word size is say 1 byte, and you have a 2 byte number, then you have to deal with it using the least significant byte and most significant byte separately somehow. How do you deal with it? Well, you can use, for example, if so your word size is this 8 bits, and the number is actually 2 words long, another 8 bits. So obviously, if you can look at it from paper side of things, if this is the D0, this will be the D15. So this will be your LSB, the significant byte. This will be a more significant byte as usual. that we know already. So you deal with this under program control, for example. So what happens is sometimes, okay, blocks of code, you know what code is, right? This is the instructions, okay. The blocks of code are preloaded as PCBs, okay, programmer control blocks, okay. So once that happens, what happens is small blocks are loaded there, and if number like if a situation like this arises, then the PCBs are used to deal with something like this. That means to say that what will the programmer do? The programmer just will provide with this, but in the underlying sequences where it gets when the program gets translated by either in the microcode level or by a compiler, then or say for example, so when that is translated, the program control blocks come into play and they deal with it in such a way that the least significant byte is dealt with, then the carry is taken. For example, if you're adding two 16-bit numbers, but your word size is only 8 bits. So your word size is only 8 bits, the memory units will be 8 bits, the accumulator size will also be 8 bits. And you see, when the two numbers will be added, first the LSBs will be added, least significant bytes of each of the numbers will be added, then the carry will be taken to the MSBs, and the calculation will be done. And then if there is a carry on the left hand side, it will be truncated, so this value will be taken. So that is exactly why if the result exceeds a 16-bit number, then we'll have some erroneous results, or we are likely to. I'm not saying that we are likely to, or we may have some erroneous results, but this dividing it between these two and dealing with it, that is done on the program control by the program control blocks. The program control blocks are provided by the designers to the users, or the manufacturers to the users. So what the user has to do, for example, if you're doing a C program, for example, all you have to do is use a big number and forget about how that big number, which is more than the word size, how is it dealt with. You forget about that. Actually, that is dealt with by the some part by the compiler, which actually indicates that this is a number which is larger than the word size. So please have some process control ready, or the program control must be brought into play here, and accordingly the processor's preloaded program control blocks are used to deal with something like that. If on the other hand we are not using program control blocks, in that case, so otherwise the programmer, okay, or the application program that is being run has to deal with the operation. So because if you are not using PCBs, then in that case the word size being 8 bits, a normal arithmetic operation or logical operation will not be possible. So you have to do it in the program. Because you don't have the PCBs, yeah, your program will have the task of now dividing it, finding out how big it is, then dividing it into the least significant bytes and the most significant bytes. Now this is just 2 bytes, it may be 4 bytes long also. In that case, it will take just 4 words totally. So you may have two 4 words number that are being compared or that are being added, and there are no PCBs. In that case, Yeah, your program itself must deal with a larger number. So you that's how you deal with uh, sequences like this. So this word size or 1 byte, when I say it's the size of the accumulator, when I say it's the lowest allocable memory unit, it also refers to the fact that this is the largest size number or data, shall we say data, that can be dealt with without breaking it. Okay, without breaking it. So the largest size data that can be dealt with without breaking. That means to say that, okay, or without breaking or needing extra effort. What do I mean by extra effort? That is, the normal instruction will work, the normal instruction is going to work, the normal effort is going to be given. As you can imagine, it is more of an effort when it is the more than one word, it is more of an effort because you have to bring it down, break it up, and then use it. So that it needs obviously needs more effort on your part, it needs more effort on the designer's part, or it also needs more effort on the programmer's part. So, and besides that, the computer also has to put in more effort because it first has to deal with this part and it deals with this part. Then if there are other parts like that, but this is, mind you, not separate, these are data larger than a word, but these are not separate data, these are actually part of the same number, so it has to deal with them like that, with caution and care. So extra effort has to be given. But on the other hand, if for example if there is a size of 1 byte and the data is contained within 1 byte, no extra effort is needed. So it also refers to that. Now you see, the size of the accumulator or the word size also refers to something called, so when we say it's an n bit accumulator, means that we have an n bit computer. Understand? So that means, when we say that it's a 32-bit processor, it's a 64-bit processor, it's a 128-bit processor, we hear some things like that, don't we? We say it's a 64-bit processor, or have you guys heard of this? That when you try to buy a new computer, or analyzing a computer specifications, it says it's a 64-bit processor, it's a 32-bit processor. We hear things like that, don't we? Hmm? Hmm. That actually refers to the accumulator size. Actually refers to the word size, the accumulator size. So this size of this accumulator, it's the largest number it can deal with at one go without having to put in some extra effort. It's normal processing, and not breaking up the processing into several parts and dealing with it with more effort. It does need to do that. That is the word size of the computer, and that is its that word size refers to when we say so much bits, n bit processor. Okay, n bit computer. N bit computer means n bit processor. So basically that means we've got an n bit accumulator, it's n bit word. That's what we actually refer to. It also refers to the fact that one of the most basic data type that we have in a computer is actually an integer. Do you realize this? So we have got obviously this a numeric representation always. The integer is the most basic data type, and in an n-bit processor, the integer is also n-bit. or normally the normal integer is normally n bit. And similarly, if you follow the trends, then the long integer will be 2n bits, short integer will be n by 2 bits, like that. You take into account. Now, you see, there is one thing here that we talk about an n bit machine. Now, we talk about, for example, Java. Java is based on Unicode, and there the integer is 32 bit. And you can see that not many processors can actually run Java. So if you take a very old operating system into account and very old processor into account, you won't be able to run Java because the data sizes will vary so much that it's not possible to run. So we have a situation like this where let's say this is the memory, and these are the size of this is one word, whatever word that is. It's normally multiples of 1 byte, at least 1 byte. So this is one word, this is one word, etc., etc., etc. And these words all have addresses 0, 1, 2. These are addresses. Now, when we are talking about processing the data, sometimes we need to take each byte into account. As you say that at least in the modern times, it doesn't make sense to consider anything lesser than 1 byte. We used to have things like nibbles. Nibbles, as you know, is 4 bits. We used to have that. But that doesn't make any sense, any more sense, at least for what we are concerned here. Obviously, when we are talking about computer architecture and organization, we are actually talking about general purpose computers. That is, the computers, for example, the ones that you use in your laboratory for your C programming. We are not really talking about uh, particularly things like the mobile phone I'm using at the moment, or the computer inside a microwave. We're not talking about those. We're talking about general purpose computers, like those where we install Windows and use our applications. So we're talking about that. Now, in those, these when we are talking about application programs and like such other like, we may need to use a byte separately. We need to use a byte separately. So, how does that? What does that actually mean? Using a byte separately. Well, let us say that coming back to the previous one, for example, here, in some cases, even if this is taken together as, even if this is the word size, let us say this is actually the word size. This is the word size, the factoring rate. But we may need to address the least significant bits and the most significant bits separately. There are several applications where we need to do that. One way of doing it is to allow each byte to be addressed. So basically, regardless of the word size, the platform may allow each byte to be addressed, and then these are called byte addressable. Byte addressable means that each byte can be addressed separately. So when we are talking about a word, if it's a byte, then fine. Memory address 0 is 1 byte. Memory address 1 is another byte. A bigger part, yeah, another byte. Memory address 2 is another byte, like that. When we talk about a word which is a multiple of 1 byte, but not 1 byte, more than that, then also this is one word in memory address 0. Memory 1 is one word, 2 is one word, like that. But when you are having to divide it, let us say if this is a 2 byte word, then let us say we need to consider this and this separately. So if I go to a memory address 0, that is actually the entire word, but I have to also access this part. How do I do that? Sometimes these also have the addresses. So that you can refer to each of the, when you can take two of these bytes together as a word, or if you want to refer to each of the bytes, then you can do so by using its address, and this is called byte addressable. As I said, going lower than that doesn't make any sense in general purpose computers anyway. Now, what is the word size? What is the, so it depends upon the designer. What how much powerful he wants to make the computer. What is the word size? Okay, whether it will be byte addressable or not, the setup will be byte addressable or not. For example, you may have a processor which is a 64-bit processor. You may have an operating system which is a 32-bit operating system, and you may be using C language in you may be doing C language in Turbo C++, which I'm sure most of you have used, Dev C++ or Turbo C++. And in this case, in when you are looking at the programs, each of the bytes will be addressable. So even though the processor is a 64-bit processor, the operating system is actually a 32-bit operating system. And although it might be argued that it is not using the processor's full power because it's not a 64-bit operating system, but fair enough. But it is still being used by the processor. The processor is 64-bit. It's a 32-bit operating system, and the word size is the so and you're using a system which is using byte addressable features, so you can address each of the bytes, not just the words. So this can be done, and this is the part of instruction set design and instruction set architecture, and this happens.